Welcome everybody to this final session of this ESCoE conference. My name is Bart. I'm at the University of Groningen and I will be chairing this session, and it's my pleasure and also honor to introduce to you the speaker of this keynote lecture, Professor Michael Pollitt. He's Professor of Business Economics at Judge Business School at the University of Cambridge. And he's also a fellow of Sydney Sussex College at the same University of Cambridge. Michael got his PhD from the University of Oxford, and afterwards he wrote about 100 articles for scientific journals. Some of them for, let's say, general interest economics journals like EJ, but also top field journals like the Journal of Industrial Economics, the International Journal of Industrial Organization. And he also published a lot of papers on journals that relate more specifically to energy and the environment. So journals like Energy Economics, Energy Policy, and many more. He's also the member of the editorial board of several journals that specialize in this type of topics. And besides his scientific achievements, he's also someone who does a lot in terms of advising, both within the United Kingdom and outside. So he has advised the UK Competition Commission, Ofgem, of WAT, but also, for example, the World Bank and the European Commission. So I look forward to a presentation by Michael, in which most probably he will tell you a lot about scientific progress related to how to incorporate the green economy or aspects of it into productivity measurement, but also what this might imply for policy making and hopefully also for economic measurement. So without further ado, I think I should give the floor to Michael. Michael, go ahead and we will enjoy your talk.
Great. Thank you, Bart. I hope everybody can hear me. Everybody can hear me. Great. It's a great pleasure to be here. Thank you all for inviting me and for coming to listen as I know, at the end of a long and I know very successful conference. Hopefully I can say a few things that are interesting and that will make you think about some of the issues around the pathway to net zero and what that implies for productivity measurement. My PhD was on productive efficiency of electric utilities, since gone on to do a lot of work on productivity measurement in the electricity sector, as well as other sectors, and then sort of deviated into other aspects of general market design for electricity markets. And I'm sort of circling back to do work now on productivity analysis on the energy sector. And as you'll see, I'm giving some credit to the Productivity Institute. I should thank them for funding the 4 papers that lie behind the work that I'm going to talk about today. And in the spirit of giving credit where credit is due, I've got a number of colleagues at the University of Cambridge that I want to thank, who did a lot of the work on these papers, including former PhD student Geoffrey Dolphin, my 2 research associate colleagues, Victor Ajay and Karim Anaya, who worked on these various green growth related papers that I'm going to talk about. I should, as Bart pointed out, I've done a lot of work with different government agencies and international organizations. And this particular work actually came out of a paper in 2018 that was commissioned by Ofgem. I think what Ofgem were worried about was that, we've been regulating the electricity and gas sectors since 1986 for gas, since 1990 for electricity. And well, what's happened to productivity growth? I mean, can we actually point to improvements in productivity growth as a result of our regulation? And I think Ofgem were genuinely a bit worried about the government turning around and saying to them, well, are you actually causing regress in productivity? So one of the things that we helped them think about was, well, okay, what are you trying to achieve with productivity growth in these sectors? Because it's not just about maximizing output relative to inputs. You've also got some environmental targets. You've got targets for the rollout of distributed generation and connecting more low carbon generation at lower voltages in the distribution grid. That all sounds quite expensive in terms of conventional productivity measurement, but of course it is a legitimate objective of the system. And as I'll highlight, we did some work thinking about, well, okay, there are these other measures that you're trying to achieve. Some of them can be monetized, and we can try and incorporate them into conventional measures of productivity. And do they make a difference to measured productivity? Answer is some do, and some don't. And some are, significant, but they're not actually that big. So of course, when you weight them properly with the main outputs and inputs, you actually don't get much impact. Okay, so one of the issues with net zero is, well, okay, let's value carbon. But actually, once you start valuing carbon, actually, maybe it's not actually worth that much relative to conventional outputs and inputs. But I'll come on to that. And thank you to Diane Coyle, who is running the Cambridge bit of the Productivity Institute. I'm sure Diane's here somewhere. Hi, Diane. Thank you for including us in the work. Okay, so I've got 4 different sets of things that I want to talk about. They're all related, but they, are separable. So if you lose me somewhere on one of them, you can come back in on some of the other ones. So I'll talk a little bit about measuring productivity growth and how that relates to the environment and environmental targets. When we think about net zero, okay, what net zero is about getting to a zero carbon economy net by 2050. So we're producing no net CO2. Might be producing some gross CO2 and then capturing it from the atmosphere and producing some negative emissions somewhere. So that's what we're talking about. It has a number of implications in terms of policy manifestations, the most important of which might be that output of energy actually goes down. Okay, so this is the first thing to think about. Energy efficiency is one of the primary ways to achieve net zero. That sounds bad for conventional productivity, and it is. Then I'll talk about the impact of green policies on growth. Some people have started saying this, that, all this talk about we can have an economy that is fueled by green growth. And somehow the economy will grow, at least as fast as it's grown so far, which of course wouldn't be hard in the UK's case. Okay, UK TFP is growing at around 0.6% per annum if you go back long enough, last 30 years, maybe. Okay, so the UK productivity growth is pretty slow. So yeah, green growth doesn't have to be that quick. But if people are seriously thinking about an economy where TFP is going to accelerate under green policies, think again. Okay, for a big economy like the UK, that's very unlikely. Maybe if you're Denmark, I think it's got to about maybe 20% of exports are green related. But we're never going to be that big in the UK. Anyway, so I'll think about the impact of green policies on growth and whether green growth actually is a sensible. I mean, I'm going to say it's a contradiction in terms. If you want to be green, you're not going to have growth. If you want growth, don't be green. Unless you can find some way of measuring it. in a more interesting way, where in a sense you're measuring your greenness and your achievement of green targets. Now, one of the problems that I would pose is, of course, green targets are a tendency to an asymptote. So of course, early on, you might get rapid increase in greenness, which if you measure it properly, maybe that will be worth something. As we get to net zero, of course, we're going to be closer and closer to being green. And actually the scope for increasing greenness is actually reducing. So actually, you might imagine that even if you did measure it properly, the effect would drop out as you got closer to 2050. And then I'm going to focus specifically on energy networks and energy network productivity. And this sort of builds on the work that we did for Ofgem. You know, saying if we include a wider range of outputs and inputs, do you get more productivity growth? Answer: sometimes yes, sometimes. And then the most fun thing and the hardest, and the thing that I think some people should maybe do more thinking about is, okay, let's run the scenario forward for net zero and see what that actually looks like in terms of productivity. Okay, you're going to have to enjoy the ride on that one. What I'm going to do there is I'm going to use some of the future energy scenarios of National Grid, who produce these future energy scenarios for the pathway of both output and some inputs to the electricity sector. They also do it for gas. They also do it for hydrogen. You know, see, okay, well, what sort of results do you get if you make some assumptions about the weighting of the inputs in terms of what's going to happen to productivity on the path to net zero? And I sort of invite people to do some more thorough work on this, because actually it's really interesting what sort of challenges you get. Just to say, we could only really do it for electricity. It's pretty hard to do it. You know, natural gas is going to be the declining industry. Gas demand is going to go down probably as inputs probably go down as well, but not as quickly. Hydrogen, gosh, what's the input? I mean, yeah, you might be able to have a pathway for increasing output of hydrogen, but nobody really knows what the inputs are going to look like. Okay, I was told, but Bart told me not to spend long on this, so I won't. But you know, what we're talking about is related to GDP growth. I am going to start off and talk a little bit about the effect on the whole economy of greenness, because we did do some econometric modeling of the all of GDP before looking at the work specifically on energy sectors. Of course, the key thing to say, which people don't pick up on in the media, is that real productivity is about the residual, isn't it? It's not about the increase you get from just putting in more capital or just putting in more labor. Okay, it is about the A factor, and that is what total factor productivity is about. So one of the things which you're all no doubt familiar with is the UK economy has been growing, but it's mostly been growth of inputs, both capital and labor. Actually, a lot of it has been increase in labor hours. Has actually been just gross labor. You know, not even the labor quality improving and the mix of labor getting more productive over time as more people have been to university or get higher level skills. So we were sort of looking for this technology improvement, which is not just about increasing the quantities of the inputs. Okay, now, and here are the things which I'm going to be alluding to some of these things as I go along, which are actually where the bodies are buried on productivity measurement, as I'm sure many of you are well aware, but it is worth highlighting what some of them are. So productivity growth is about when the real value of output grows relative to the real value of inputs. Of course, So it's quantity of output over quantity of input at the simplest level. That is what productivity growth is about. If we start with financial values for the inputs and the outputs, of course, we have to deflate them properly. So one of the key things in GDP is deflating input and output deflators, double deflation of different deflators being applied to the outputs and the inputs. If the quality of the outputs is changing, that's quite difficult. Does the price deflator actually account for quality? So the well-known effect on the US productivity puzzle with the impact of computers. Computers appear everywhere, and the internet appears everywhere in life, but it doesn't appear in the productivity statistics because adjusting for quality of the computer actually turned out to be very difficult. So one way around the indexation problem is to use physical measures of outputs and inputs. This is quite interesting in the energy sector because, of course, we've got very good measures of physical output and physical input. So one of the reasons why I did my PhD on this was because, of course, you can get physical measures of electricity output, and that's pretty homogeneous, you would think, from time period to time period. One of the little puzzles which I posed to the ONS is, why does the ONS statistics show output rising in the energy sector, even though all the physical measures show output falling since 1990? Or so clearly there's, some of the indexation isn't working quite as you might expect if you look at the physical outputs. But I'm going to use some physical outputs and inputs to get rid of the indexation problem. There's also a weighting issue. So we've got multiple outputs, multiple inputs. How do we weight them? And that's important when you're using financial measures of inputs. Okay. One of the ways to get rid of it in what I'm going to do is, of course, to use a technique like data envelopment analysis, where essentially you arbitrarily assign the best possible weights to look for the highest level of productivity. So the sort of weights are self-determining, and they're not coming from some external calculation of what's the weighting of capital and labor in inputs. So you have got a weighting issue. And I think the final thing I'd want to highlight is, in theory, we could, and this is I think this is the most difficult thing for me to get my head around. In theory, we could see productivity growth in the future arising from both a physical increase in output relative to input, or that for some reason the quality of the output is rising. Of course, and so incorporating quality directly into your productivity measure may be a way of coping with this. But of course, here's the rub with net zero. One of the issues around net zero is nobody seriously expects the quality of the output certainly in the energy sectors to improve. Nobody expects that. If anything, we're going to struggle to maintain existing levels of reliability in the energy system. We're going to have to employ lots more backup, lots more storage, just to maintain current levels of quality. So yes, it might be true that physical output is not going to be rising very rapidly as a result of net zero, but maybe the price of it, the real price of it is. But even that sounds quite challenging. So there's some really fundamental issues around measurement in here. And so in the first bit of work that I'm going to think about, we just do some conventional modeling of what's happening to the change in value add, both at the whole economy level, so GDP, and at the energy sector level relative to changing outputs and inputs. appropriately deflated to get this residual total factor productivity measure. Okay, I said it's a bad story. Has anybody shown this picture before at the conference? So this is the UK output growth. So output did grow between 2008 and just before the pandemic, but mostly it's hours worked. And multi-factor productivity growth, well, it fell to begin with, and it's not above zero, the total contribution. So I did say that if you go back far enough, you do find positive total factor productivity, multi-factor productivity here for the UK economy, but not for this recent period. So the UK economy has not been becoming more productive, which is worrying. So what if you use the CLEMS database, which is the best database, so I'm told, for making EU-wide studies on different growth rates, you do find that both for the whole economy, which is in red, so this is TFP growth for the whole economy in red, and for the electricity and gas sectors, because CLEMS database has some sectoral breakdowns. This clear change between before 2008 and after, with productivity being significantly lower. Now, of course, the interesting thing is that some energy sectors really see very big drops in productivity post financial crisis. The Japanese one is perhaps easiest to explain because of the Fukushima crisis. So, you get massive increase, reduction in output, massive increase in inputs, and massive reduction in productivity. But that's true across a range of different countries. Yeah, so and basically, if you look at, contributions to value added growth, so this gross measure of output itself related to GDP, basically, productivity after the crisis, total factor productivity contribution, which is this purple bit, makes no contribution after 2008. So of course, one of the questions is going to be why, and can it be related to what's happening with net zero policies? Because 2008 also happens to be the year in which, there's very significant increases in net zero commitments. The UK passes the Climate Change Act. Other countries get very serious about this. EU policy begins to be tightened substantially towards achieving deep reductions in decarbonisation, increasing amounts of renewables being added to the electricity system, deep targets for reduction of demand from the energy sectors, trying to make the economy more energy efficient. Yeah, so and what's true, again, there were this purple TFP is increasing before 2008, these 10 years, because CLEMS database unfortunately goes back this far. Before the financial crisis, there is some positive contribution in some countries. It's negative in the UK. UK is just bad at productivity, as we know. But it gets a lot worse. There's more negative contribution in the electricity and gas sectors to productivity. So, is that surprising? And at a basic level, I don't think so. So, basically what, European energy demand, so this is final consumption of energy measured in units of energy, peaks around 2005 across Europe. This isn't Europe, but these are different European countries, but it's true at the European level. Basically, energy consumption now is lower today, or lower in 2019, than it was in 2005. And that is true across a wide range of European countries. Okay, and the drop, is pretty significant. It's at least 10% from the peak, if not more than 10%. And this is all energy. Then this is in spite of the fact that transportation energy is growing. So some sectors are growing, and in spite of sort of potentially rising demand for underlying energy services, which may not be being measured properly. So there clearly is some sort of statistical, at least, association which needs to be explained. So we did do some work on this. Did a nice paper which examines the impact of both competition policy, because of course, well, my colleagues were interested in whether this could be due to, regulatory, the openness of markets reducing over this period, as well as key things to do with the energy transition. And we do find a correlation. Now, of course, I'm not going to go large on, there aren't many other potential explanations, but it is at least interesting to observe that there does seem to be a relationship between increasing renewable capacity, reduction in demand, both of which we measure separately, and increases in energy market regulation. So there was some effect from the competition effect. These things appear to statistically significantly reduce the absolute level of TFP in electricity and gas. So there would appear to be an energy demand effect on negative on TFP. So that was just looking at the electricity and gas sectors. We also looked at the whole economy, and my colleague Geoffroy Dolphin, who's now about to start the IMF, I'm very pleased to say, find that higher carbon pricing, and Britain is a high carbon price country, so now higher carbon prices might be associated with a tighter, more net zero consistent policy, and also higher levels of renewable output are associated with economy-wide TFP reductions. Okay, so and again, one of the myths about net zero is somehow nobody is going to notice net zero. That one of the political myths about net zero is nobody is going to notice. That is rubbish. Okay, we're all going to notice. We're already beginning to notice. Nobody notices maybe if it's just about electricity. People notice big time if it's about transport or if it's about heating. As we're about to find, decarbonizing the heating sector is going to involve massive cost, massive disruption, reductions in demand, big rises in unit prices, and people are going to notice that. And what I'm suggesting here is maybe we're getting some early signs this is going to impact negatively on TFP, unless we maybe measure it better. Clearly this is conventional TFP. Okay, so I'll try and cheer you up a bit later. Okay, so as I pointed out, of course, one of the things I love telling my students about is never try and pass off an increase in inputs as an increase in output, because politicians, of course, are doing that all the time. This is a good example of, what's good about, certain technologies is, how many jobs you get per million of expenditure. But why would that be of interest? But, people are advocating green investments as a way of promoting economic growth and sort of promoting productivity, when of course what we're actually talking about is pushing more inputs into the system to get some difficult to measure benefits which might not show up directly in conventional measures of output. And it's important to, this is not an old discussion, is it? Sorry, this is not a new discussion. You know, valuing environmental services properly has always been a big issue. You know, and good that we're beginning to talk about it more. You know, how do you value ecosystem services? How do you value carbon reductions? You know, temperature reduction in general. Yeah, and famous book, The Economics of Good and Evil. He, you know, I think Sedlacek is his name. You know, we have this assumption that more output is a good thing in our economy and in the way we set our statistics up. Of course, that's not necessarily true, that less production may be better. You know, he gives this lovely example in his book that, you know, the most unproductive relationship in economics is friendship. You know, family relationships, of course, can be very economically productive. You know, my children look after me in retirement. My spouse looks after me when I'm sick. Those are economically productive relationships. Whereas just meeting somebody, as I did for breakfast today, just to have a chat, that is, you know, a waste of time. I should have been working. Okay. Maybe you think I should have been working. Anyway, there's a lovely paper by Dixit and Grossman who point out that, you know, the monkish lifestyle where you spent your time, you know, praying and tending your garden and helping the poor, that would be a terrible for GDP. Okay, it would be absolutely fantastic, one assumes, for one's mental and spiritual health. But, you know, these things aren't good for GDP. And of course, what I suggest is the circular economy, the net zero economy. We need to work out ways of measuring how successful those things actually are, because conventional GDP is not going to measure them properly. Here's a very nice paper, which if you haven't read it, you must read it because it's really good. Apologies for the non-woke language, but it was 1966. So Boulding makes this really interesting point that GDP growth and conventional measures of growth are all about extending human activity to uncharted plains, rather like, and he calls that the cowboy economy, where you can always put in more capital, more labor, more land to create more output. And he contrasts that, and I think this is the visionary thing about this, to, you know, the space person economy, where you're in a closed system and you need to worry about the fact that you can't just keep increasing throughput. That's actually not physically possible. And of course, he writes it about in the context of the planet Earth, where we need to think of this as a closed system, where actually we just need to recycle things better. And that increasing output actually isn't possible because it is like a spaceship increasingly. And we can't keep thinking about it as a sort of cowboy world. And this is related to the steady state economy, which Herman Daly was writing about. You know, these people were laughed at as, you know, radicals when they wrote these things, and now they look extremely prophetic. You know, that they actually understood the way things were actually going to go. So, you know, Daly talks about the steady state economy, where, you know, you can increase service relative to throughput, but you need to be, you know, you're constrained by the stock of resources that you have, and stocks of capital and labor are finite. So in spaceship economy, you can't increase either labor or capital because that's what's closed. You can learn things, and so you can increase throughput through knowledge, but knowledge is the only way that you can do that. You can't keep putting in more capital and more labor, and also you know, if you're in the spaceship, yes, of course you can run your capital harder and your labor harder, but of course if you run it so hard that it breaks, you can't fix it. You can't just get another piece of capital. There isn't another spaceship that you can be on. So you need to worry about the physical limits of throughput and how it damages your capital and your labor. So, okay, so we need to measure productivity properly, and that's not. And I'm going to talk a bit more about can that be done easily. And we all know about the example of the internet and how things that are given away free in the internet don't appear directly in GDP, even though they do create value which should be measured. They're not appearing in conventional GDP. Now, no doubt Hal Varian, who I think probably still is the chief economist at Google, is exaggerating. I'm not sure people are willing to pay 65 billion. Yeah, that first search of the day, that's really worthwhile, but the 25th one, I'm not paying anything for that. I'll just do it once at the start of the day, thank you, if you start charging for this. And GDP growth, that is difficult to measure because of this indexation problem. And I'm sure you've heard other people from ONS talking about how you index both output and input separately really matters. That's why we had apparently productivity growth in UK telecoms was quite low. And if you valued the output, if you properly deflated the output, you'd find that the output actually rose much more quickly in the first early stages of the internet than it appeared, and hence productivity was much higher in the telecom sector than it first appeared. Okay, so just a couple of things on, okay, could we not just ditch productivity growth as we head towards net zero and only worry about hitting our environmental targets? It's worth pointing out that we can't forget that the size of the economy was measured for a reason. Okay, the size of the economy was measured for a reason because it meant we could borrow more if we had a bigger economy. And if we can borrow more, that means we can smooth consumption between now and the future. If we can only borrow less, then we need to worry about the fact that we can't borrow for the future, and we need to redistribute more in the current generation, which is possibly what we're finding at the moment. And actually, if problems that can be dealt with through borrowing have to be dealt with through redistribution if GDP declines. So this is not just a sort of academic question, but has real sort of policy and social implications. Other people have sort of started saying this, that the end of the carbon economy, which is a cowboy-related economy of infinite horizons, means that the cost of capital is likely to fall, measured growth rates are likely to fall, reduced opportunities for throughput growth, an increased stability of demands for all sorts of things will reduce riskiness of investments, or at least it should do, which will reduce returns. Increased need to put capital into the system to replace fuel, for instance, will mean that risk premiums will get focused on. People will ask, well, hang on, if I'm putting all this capital in and you're going to get guaranteed services and provision from, say, the heating system or the electricity system, why am I giving you a high risky rate of return? Because actually your level of service is guaranteed by the customers that you've got. So that will, we're already seeing Ofgem under pressure to reduce rates of return to regulated energy companies and to unregulated ones as well. And that squeezing of returns then may have ownership implications. We've already seen calls for renationalization of certain parts of the energy sector. And that's partly driven by increased focus on the fact that we can't think about future growth. We have to think about current redistribution and current rates of return and whether they're fair enough. Okay, so should the government promote green growth? Now okay, so green growth obviously has got the advantage that you reduce carbon and there may be other air pollution benefits. And actually those can be very large. Lovely book by Roger Fouquet on heat. And he shows that actually, you know, the external costs of air pollution in the UK were exceptionally large. By about 1890, they were, you know, 25% of GDP. And actually, he's got a lovely chart in his book where he shows that it sort of began to come down gradually from 1890, and then in the 1920s, it sharply dropped. Okay. So, you know, if you had been measuring growth in the 1920s and had adjusted for this big improvement in relative air quality, you'd have got even faster growth in the UK than you got. So this was a really big productivity improvement, which went unmeasured in GDP. You know, one of the things that was happening behind this is the dirty economy was really significant in the UK. You know, the dirty economy was that 6% of all employment was in coal mining in 1920, and of course it's virtually zero today, and fell very rapidly in from its peak in the 1920s, fell from the late 1920s. So, you know, we moved from a dirty economy where dirty goods were generating a lot of GDP to a much cleaner one quite quickly in the UK, actually. And that was unmeasured. Okay, so I've sort of said this. You'd expect somebody who is a professor of business economics at a business school to say that they don't think government industrial policy in the UK is likely to be successful. It's been rubbish so far. There's not, and I can say that anybody who perhaps had a similar education to mine, shall we say, where I spent my undergraduate days being told by fairly left-wing professors how brilliant industrial policy was, it wasn't in the UK. May have been great in Japan, may have been great in Germany. It wasn't great here. So, but yet we're seeing this creeping back in with green policies and strategies. I had great fun debunking this. You know, you read something like this, you find that the government is advocating, you know, people doing more walking and riding their bike to work. Now, of course, that's absolutely great for the environment and for our physical health. It's terrible for GDP. That's not an industrial strategy in the conventional sense, but also promoting industries which might involve putting in huge amounts of inputs and not getting much output. That is also, going to raise big questions for future productivity. Okay, so as I sort of alluded to this, you know, as we head towards net zero, will the economy still grow? Well, it sort of depends. You know, we can think of, you know, there's the sort of cowboy resource economy, and then maybe there's the solar economy, which is more like a spaceman type economy. And, you know, maybe there are lots of sectors which don't depend on material inputs, and maybe those will grow. But of course, maybe they'll be like the internet and computers, and actually they will grow, but they're not going to show up in productivity statistics. And I mentioned, you know, the UK is not Denmark. So, you know, maybe I hope I'm wrong, okay, that there's going to be productivity problems. But, you know, it's not promising when you start thinking about the underlying theory of the green economy and the evidence on the green economy. So that's not to say that greenness isn't a good thing or that it shouldn't be properly measured. It is simply to say that there is likely a green productivity measurement problem. Okay, so that was sort of by way of talking about the green economy generally. Let me circle into network, what am I doing? Network company productivity. And I'll say a little bit about this because I think before I want to come back to my final point about future productivity prospects. Just to say on the network sector productivity is nice because of course as I said, the inputs are well measured and the outputs are easily defined in terms of things like amount of energy or number of customers. So getting physical measures of output and then combining that with suitably deflated measures of capital and operating cost input is relatively straightforward. So Ofgem asked us to do this. And the question is, if you include wider measures of outputs and inputs, do you find much difference in productivity? So that is the fundamental question, okay? And so we're going to use, weighted outputs over inputs, this Malmquist DEA approach. And yeah, we're going to deflate capital with the gross fixed capital formation price deflator and Opex with a wage index. So we're separately deflating the inputs to try and get a measure of input quantity. I'll try and show you for the 4 different industries. So we've got electricity transmission, electricity distribution, gas transmission and gas distribution. So we've got conventional outputs, so measures of energy and also the sort of peakiness of the system that you have to serve. Opex and Capex, and then one of the things that we were trying to help Ofgem with is, well, if you value the improving quality, does that make a difference? And then also if you include the fact that there's less emissions being produced within the business of transmission, so there's less losses in the transmission system. Have you valued that properly? And we also include the non-availability of the system. So, as I said, energy transmitted is actually falling. The network is growing slightly and Capex is rising, but Opex is falling. Okay, so it's not immediately clear what might be going on. If you adjust for the value of lost load and emissions, it makes some difference, but actually not very much. So this is one of the problems. Once you start including some other quality variables, actually, if you value them, they may not be that significant relative to conventional costs. And of course, that's going to matter for whether the productivity improves that much. We think about it over different price control periods. And so what's the bottom line? So the bottom line is, over the whole period since 1990, productivity is growing at 1.1%. If you just include conventional outputs and conventional inputs. And it makes, if you include the value of lost load, that does improve things by 0.1%. Well, it's 0.1% per year over 20 odd years. So that's worth having, but it's very small. The other things don't improve things. So you can include them, you can have wider ranges of outputs and inputs, but it doesn't actually make any difference, which of course is the issue. So then we go to electricity distribution. We've got more data there. So we were in a long discussion about Ofgem about, well, can you not get more data on like amount of distributed generation you're collecting. We did try and value, include things like customer satisfaction, because satisfaction with the network is improving. And again, we put in customer minutes lost. We try to value that, so that we know that what the monetary value of a customer minute lost is. Then we also put in corporate emissions reductions and the value of lost load as well. Again, does it make any, get same picture, energy is peaking, going down, network is getting longer, so it's a bigger network to serve, and CapEx is going up a bit. There's big reductions initially in operating expenditures. You might be some productivity improvement there. And if you include customer minutes lost and Opex, the costs do get higher, and you get some increase towards the end of the period in relative costs. So again, you've got different price control periods, which we break out the productivity growth for. Again, what's the bottom line? So here's the basic model gives you 0.8% per annum, where we're just using conventional outputs and conventional CapEx and Opex inputs. And actually, if you include customer minutes lost and adjust OPEC operating expenditure for that, that creates quite a big 1% per annum for 27 years increase in productivity. So that's actually really quite, because customer minutes lost start off very high and fall, so the costs start off much higher and then fall less if you include customer minutes lost. Putting in losses improves the reductions in actual energy loss through the distribution system also improve things a little bit, but moving to these much wider measures doesn't seem to make much difference. So some things are very significant. Some improvements in quality can be very significant. Okay, then we move to gas. The data is getting worse now. Note to ONS. So now we've got Opex and CapEx, conventional measures of both the system size and the amount of energy being transmitted through it, so both directly to GB and across to other countries included as well. So you can include shrinkage. So this is sort of loss of gas, leak of methane through the system. That's actually quite costly, as you might imagine, because you're paying the whole price of that as extra cost if you try to value that. And then this is emissions related to the operation of the gas system. And again, you get this picture that actually demand is falling. So gas demand is falling. The network length is did increase a bit to begin with, but then stabilized. Capital expenditure falls a lot to begin with, but then is now rising, and operating expenditure is going up. Though interestingly, the shrinkage effect is there's declining shrinkage, so that actually it smooths out the adjusted operating expenditure and would, if you think, make the productivity growth less affected by this rise in underlying operating expenditure. Again, we've got different price control periods. We've only got data for the most recent 2 periods because the industry was reorganized and the data is poor and not comparable before 2006-07. So we've only got a more recent, shorter period. And of course, so as expected, you saw that the big reductions in capital expenditure and operating expenditure are very significant in that early period, but in the later period, where actually Ofgem moved to this wider range of outputs that they were trying to target, actually productivity does decline, and shrinkage does improve things a little bit. So if you measure some wider environmental outputs, maybe you do get an increase in productivity from minus 1.6% to plus 0.6%. Okay. So again, it's making a difference, but it's not huge, and the period is shorter. So that's not 27 years. That's more like 10 years. And then finally, gas distribution, where again, we've got some emissions cost in the gas system and the value of lost load, as well as some additional quality measures, which unfortunately Ofgem don't provide a clear valuation of this. So we can only include the physical number of that, not the financial value. Again, you get a similar picture, declining units distributed. So energy is declining, the network's getting a bit longer, and the number of customers is increasing. More gas customers, and that's more output, more extension of gas network. Capex has shot up recently, and Opex is rising. And actually, we get this effect that the emission, even if you include the environmental effect, it's negligible. So it's not going to affect productivity. And again, we've got some data from this first price control here towards the more recent period. And again, productivity is declining in the gas sector. That big fall in output really does seem to be making a difference. Basic model is giving you minus 6.2% per year of this over this final, over the whole period. And it's only improved slightly by including a wider range of outputs. So the actual effect is pretty marginal. So, you can improve things, but actually, it doesn't improve consistently, and not for every sector. And there's clearly a big problem in the gas sector, which I said was looming as we decarbonize the heating sector. As units decline, if anything, inputs are going up. We're not seeing big rises in productivity there. We're seeing productivity regress. And I suppose the main thing is trying to monetize the quality variables, and the environmental variables only has limited effect, because actually the monetized value tends to be quite small. So, is incentive regulation effective? Were Ofgem doing a good job? Well, a wider range of outputs does help, and there is some evidence of improvement, especially for quality of service related things. But it's important that Ofgem get better at measuring what they're trying to do, so that we can try and incorporate it into measures of productivity in order to see whether they are doing a good job, and how improvements in one area actually weight against other improvements, or against standardized capital and operating cost expenditure. Okay, here's my last thing, and this is a fun bit. This is what I spent a lot of time sweating about. Okay, so what about on the road to net zero? Okay, so what are the prospects? So that was, recent years, electricity and gas networks, outputs not rising very much, inputs are rising, productivity is not rising that much, okay, or falling. What about out to 2050? And here I'm going to use the, National Grid electricity system operator do produce these very interesting future energy scenarios, where they've got projections of inputs and outputs for every year out to 2050 for certain things. And I'm going to combine these with other data, and then running a simulation is perhaps an overstatement, okay? But so this is what they give you. They've got this is 2020 out to 2050. This is one of the scenarios that I'm going to use. It does reach net zero, okay? So we do decarbonize the system doing it. And they give you like output in every year, so you can work out output growth, and they give you a measure of input. They give you gigawatts of capacity in the electricity system. Okay, so that's a good place to start. Okay, so what I'm going to do is I'm going to think about raw productivity, which would be just looking at the terawatt hours of energy and the inputs of gigawatt capacity. So the simplest possible measure of productivity, output over input, relative growth. And then also I'm going to, now I'm employing all that I've learned about, from the CLEMS database. Okay, then we're going to do a little bit of financial simulation to try and tease out some of the weighting issues. So if you start from the value added in the electricity sector and from fuel costs, and you use the relative weights of capital and fuel, I can now simulate capital growth and fuel growth capital growth and labor growth, and I can simulate fuel growth. So I've now got all three of the inputs, and I can have them increasing at different rates according to how I weight them. Okay, some of them I'm going to have them growing in gigawatt relative to gigawatt capacity, and some of them I'm going to have growing gigawatt capacity here, and some of them I'm going to have them growing relative to the expected decline in fossil fuel capacity in the electricity system. Okay, so what you can imagine happening, I've got different scenarios for what's happening to the total mix of inputs as gigawatt capacity grows. It could all just be on gigawatts of new capacity, or I could be letting the expected fall in fossil fuel costs actually reduce inputs, and then I could take the expected fall in fossil fuel costs and actually apply that both to the labor cost as well, and let that fall in line with fossil fuels too. Okay, that sort of gives you a sort of bracketing pair of projections. Okay, and then, so this is it. Okay, having done that. So the interesting thing is, if you do raw productivity, you've got, here's the problem. The problem is National Grid are projecting a big rise in gigawatts in the electricity system and a much smaller rise in output. Of course, that's not unexpected, because renewables, of course, have got low capacity factors. Okay, so not very productive. So that would give you a big decline in raw productivity, which actually begins to unwind in the next 2 decades, because electricity output starts rising as a result of electrification. Okay, so you actually get quite strong electricity output growth in the 2030s, and the capacity growth starts to moderate. So you actually see raw productivity improving. Now, of course, this is where the Clem's weighted inputs comes in, and this is in response to a very nice comment that we had on the first draft of the paper. Well, what if the inputs don't grow fully in line with raw gigawatts? They actually, I'm going to weight the fact that the fossil fuel is declining. That means that inputs don't grow as rapidly as they do here, and actually productivity actually doesn't decline as much in the first period and grows a bit more in the second 2 periods. So that's about getting attributing a benefit to the fact that the capital may be rising, but the fuel is falling. Okay. And I could take that even further and say, oh, well, okay, what if that fuel benefit also just spilled over into a benefit to reduce labor as well? So labor is now falling. This would be, really extreme scenario, because you end up with no labor in the electricity system by the end. Well, then the inputs fall even, the input growth is even less in that case, and the productivity growth is more substantial. And what it's still true. The point is, however you look at it, if we're on a path to net zero in the 2020s, productivity is likely to decline. Very difficult to see how it won't, measured productivity. But maybe in the 2030s, there is the prospects of quite a big increase in productivity, because we'd see electrical output increasing and inputs actually beginning to decline. With the fuel begins to drop out of the system, the labor begins to drop out of the system. And that, then growth moderates in the 2040s, and actually the productivity is still rising, but more slowly. So, what does that mean? I think it means that 2020s are very challenging for productivity growth in sectors like electricity. I haven't talked about gas. Gas productivity is going to fall, a lot more there. But maybe the 2030s and 2040s look more promising. And of course, I've done nothing about, that was just pure capital effect, labor effect, and fuel effect. I haven't talked about valuing the environmental externality. That would be in addition to this. Okay. So, you know, it is, you know, there is some good news, but in the short run, if we're serious about net zero, it looks like a lot of input for not a lot of output in the next 10 years, certainly in electricity, I think. Green economy, pretty challenging. Net zero, I think, does provide a big headwind for productivity growth because the circular economy in general does. Yeah, productivity in energy sectors in particular is likely to be directly affected by net zero policies, and difficult to see anything other than quite negative TFP in those sectors. Certainly lower cost technologies would help. And if we can really deliver these big reductions in fossil fuel use and in labor use in the energy sectors, yeah, maybe you could get productivity improvement there. Thank you.
Thank you very much, Michael. There's time for questions. Who would like to get the first microphone? Over there. There is a microphone, so let's wait for it.
Yeah, thanks very much, Michael. Very, very interesting, and of course, a very important topic for all of us. I just had a sort of slightly technical question on some of your approaches. It seems to me that you treated emissions, environmental impact as a cost, an additional cost, an additional input. What was the rationale for doing that rather than treating it as a sort of quality adjustment on output, which is the way that I sort of intuitively think about it? Thanks.
Good question. So in the work that we were doing on electricity and gas, we had physical outputs. Okay, so the financial quantities are on the inputs. So it's even natural to adjust the inputs by the reductions in, you know, the cost of emissions. So putting it in the outputs, we can't use we mightn't be able to use a value there. So I mean, I think, you know, the fundamental rationale for doing that is you're putting, you know, you're spending environment to create this output. And that is, you know, one can think of it as a cost, can't one? So I think conceptually you can do either.
Martin Wheel from King's College. Thank you for a very interesting talk. In one of the slides, it flashed up a reference to minutes lost or connections lost, and I wonder what price you were putting on power cuts. And you also referred to an adjustment for consumer satisfaction. So again, could you say how you were valuing those relative to the costs of the capital and labor and fuel inputs and so on?
Thanks, Martin. Yes, so the great thing is that Ofgem, so certainly for electricity, Ofgem actually do put a value on customer minutes lost. And it's quite a large valuation. It's sort of the order of, you know, £1 million per minute lost per company across their customer base. So what we actually did was use their valuation, but we actually made a further adjustment, which was to actually look at how the companies were doing relative to projected customer minutes lost. So we're not giving them the full benefit of saving customer minutes lost, because some of the productivity improvement would have, you know, is to be expected. You know, things will improve anyway, and so the companies are only beating given credit for beating the targets of Ofgem. So the answer is it is quite valuable. You know, so you're talking about typical distribution company might be £100 100 to 200 million of operating expenditure. They've got something like 60 customer minutes lost. Those are each valued at a million a throw. So that could, that's up to 60 million relative to, say, 200 million of cost. So it's quite a big potential benefit.
How does that translate into the price I that is effectively put on me having my power cut off for half an hour?
Okay, so the answer is, if you are cut off for that time, there are standard payments that are made, which actually are similar to those sorts of levels of payment. So does it show up in people's bills? The answer is yes. So one of the things that Ofgem are actually trying to do with their regulation scheme is to reflect customer values of minutes lost in the incentive scheme that the company faces. So actually you have got quite good estimates there. And if anything, you might argue that the estimate is overvalued, because of course, at the margin, and a reduction in one customer minute might be worth $1 million. But of course, if you reduce me all the way down to 0, that last minute might not be worth $1 million. I might only value that much less than $1 million. Yeah. Thank you.
Thank you. That was a great talk, Michael. Thank you. I'm just trying to think through the kind of general equilibrium effects of those simulations. And if you think about whale oil stopping being demanded, the productivity of the industry took a big hit because they still had to run some ships until it collapsed. But then it didn't matter because there were other things. So how did you think about those sorts of longer run general equilibrium changes over 3 decades?
Okay, because that's a really great question. So so with electricity, it's not like whale oil. Okay, so I think the point about electricity is electricity is actually the prime sector delivering net zero. So actually what we're saying is about this, net zero is primarily being delivered by electrification. And what I'm saying is the statistics look like productivity will go down in electricity. I think you're right about sectors like gas. Maybe it doesn't matter that gas will show negative productivity. Maybe, but I think the likelihood is sectors like both the methane sector and say hydrogen, they will exist in net zero and they will involve lots of inputs relative to output. Okay, so I think this is not just a short run effect where these industries will eventually disappear and all their resources will be reallocated. I think we're looking at a large number of sectors which are going to permanently have more inputs in them relative to real output. And I think this is where the ONS statistical problem comes in. How we value that will become important.
Time for one more question. And I'll explain later why there's just time for one more. Yeah, Bart, go ahead.
Well, thanks, Michael, for a great presentation. Although not the most optimistic one to leave this meeting, but it is what it is. And maybe not trying to make things worse, but I'd like you to reflect a little bit on the circular economy and your statement there also in the 3rd paragraph, that's where you would hope, or at least you have sort of a little bit of a hope that we might see productivity gains there. Now let's think this through a little bit. Because the circular economy, I think where you would have the productivity gains is that we're going to save on intermediate inputs. That's the idea of the circular economy, is that we're not continuously putting in more intermediate inputs. We don't actually measure that very well in sort of the traditional growth accounting because it's part of energy materials. And So the question is, first of all, what are we going to pick up in terms of productivity gains in a circular economy? And maybe a second question to that is, there's the other big transition, which is digital technology, which you didn't talk about too much, but the question is to what extent digital technology can help us to reduce the adjustment cost a bit.
Yeah, I mean, I think the hope with the circular economy is that you can fix the inputs and actually just make things go round more quickly, can't you? So you're producing more stuff, somehow you're selling more cars, but you're recycling the parts more quickly. So I think there would seem to be stuff that you can do there, but it's pretty challenging. So yeah, absolutely. I think generating productivity growth in the circular economy is going to be tough, because one probably will find there's some critical inputs which you have to put in, which you can't make fully circular. I think on your general question of whether digitalization gets us out of everything, I think, yes, we can imagine that we will have an economy which is more dependent on digitalization, but I mean, one expects that the long run trajectory of any economy in the best possible world is that more people end up in services and more people are doctors and teachers and in entertainment. And eventually I was just thinking about this morning, eventually I suppose my question would be, eventually we just end up measuring work tasks. If we're really adjusting output and input carefully, we just end up measuring hours of work, don't we? And actually that will just be fixed. So there's only a certain number of emails I can send a day type of thing, or that are certain that are useful. And if I just end up measuring that properly, you just end up measuring my hours of work. And I think that is really the challenge as you move towards a fully service-based economy, that you can't, that we've had an economy where material productivity has been the driver of big increases in productivity. And that is going to come to an end at some point.
Okay, thank you very much. Thank you very much, Michael, for this. Maybe there were additional questions, but these can't be answered or can't be posed or answered right now, because I've just been informed that at 12:30 there will be a fire alarm exercise. So I would like to call Mairi forward, because Mairi Spowage is giving the final comments, concluding this meeting, concluding this conference. So there are 9 minutes left, Mairi.
Yeah, thanks, Bart. It's always good to have an alarm end on your closing remarks. But I always find that the most popular form of closing remarks are very short ones, so that you can all get on your way. But I think, well, I hope everyone would agree that we've had a great few days discussing the latest challenges on measuring the modern economy. I hope you've really enjoyed coming to Glasgow. We've certainly enjoyed hosting you in our Technology and Innovation Centre here at Strathclyde. I particularly enjoyed the provision of quite Scottish cuisine. Macaroni pies and haggis bonbons were my highlight. And if anyone is feeling a little tired after a few too many drinks last night, then make sure you grab a can of Iron Brew on your way out. That will pep you up. I think I've had the privilege to be involved in ESCoE since I moved from being a statistical producer into academia in 2018. And I think I've finished this conference with a renewed realization about just how special ESCoE is, allowing ONS to work in partnership with academia, to allow researchers to put their minds, the big challenges that there are in measuring the modern economy. And also allowing us in academia to work with ONS and bring in these insights into advances in statistical production, having a real impact on how these things are done in practice. We see with the topics that are being discussed, I think, at the conference over the last few days, that where the big issues are in terms of the sort of frontier of measuring the modern economy. So whether these are about how we can or should expand the production boundary, the challenges or opportunities in measuring activity at the subnational level, which many of you know is one of my areas of interest, or when we're thinking about, and this is particularly apparent, broader measures of success, given the challenges we have with both inequality and decarbonising the economy over the next few decades. And as someone who also has the privilege of teaching students, being able to research in this area allows us to inspire the next generation of economics students coming through, that there's significant amounts of research interest and careers in economic measurement, not just in economics. So I really enjoy making sure that students are inspired about national accounts and economic measurement. It's been marvellous to have this in person, and I think all of the benefits that you get from being together physically cannot be overstated at all. And I've really enjoyed being together with everyone, seeing lots of old friends and old colleagues as well, made some new friends as well, and made some contacts which are going to lead to future collaborations and conversations about future work, which is what it's all about. And if nothing else, we get to have good chats about things that we like to get our geek on about when we're all together, talking about national accounts or public sector finances in my case. So as tradition would have it for closing remarks, just want to thank a few folk. Thanks to Rebecca for asking me to close the conference and for leading ESCoE over the last few years. Thanks to our scientific committee co-chairs, Gary, Bart and Sanji, for keeping us on the scientific committee in line and making sure we were doing what we were doing when we were supposed to be doing it. Thank you to the vast amount of people who were involved in the programme committee in helping assess the papers that we were able to present at the conference. All of our presenters, of course, and those who produced a poster, which I thought was a really great session last night and sparked lots of really interesting conversations over a few glasses of wine. I think my biggest thanks, though, will go to the people who organised the conference, because we all know how much work goes into organising something like this. So for John and Sarah, ESCoE, of course, Nathan, Emily, Caroline and Sharon from ONS. We all know how much work this takes, and thank you so much for all of your efforts going into what's been a very well organised conference. And I'd also like to thank the guys here at TIC, the security and catering staff, and of course the AV staff, for making sure that our hybrid experience is seamless for everyone participating. So safe travels, everyone. I think I've finished before the alarm's about to go off, and we'll see you all again soon. Thank you.